Determine the time needed for the load at B to attain a speed of 10 meters per second starting from rest. If the cable is drawn into the motor with an acceleration of 3 meters per second square. So let's start by assigning our coordinates, as usual, SA, SC, and SB. And by looking at the problem, we have the final velocity of B, which is 10 meters per second. We have its initial velocity from rest equals 0, and we need the time. So we can use the first constant acceleration equation, which is v equals v naught plus a times t. And our unknown here will be ab, which can be found from the dependent motion using aa. And going back to how to solve, we already found the relationship to be 3ab plus 2aa equals to 0. And using aa as 3 meters per second square, we can find ab to be minus 2. And minus 2 means 2 up in the negative direction. And now we can find the time using two different ways. Choose what you want. The first method is assuming positive down. So we have this constant acceleration equation. Vb final will be minus 10 because it's up from rest equals to 0. And AB also will be negative because it is up. And from here we can find the time to be 5 seconds. And using the opposite direction, so positive will be up, VB final will be 10, and AB will be 2. And this also leads to the same answer, which is 5 seconds. And notice in both cases that we get the time positive, which makes sense. So if you get the time under any circumstances as a negative quantity, then you have to suspect the directions of the variables that you're using in the equations.